That's still cheating.
She touches me every day.
I would say it's at least what, 865?
You don't even know her.
I have no idea what we were getting at. But I was right. You drive a Bugatti.
It's done total. But I get the phone.
Ryan, are we ready? You drive a Bugatti?
I love you, Daddy.
I don't even know if I want to unpack what's up with Bugatti.
Ooh, Bugatti?
Well, I have a question. Did y'all wake up in a new Bugatti? All right. So, are we ready to get going? All right. So we understand you guys have been talking about meteorology in class. You finished your weather unit, what, last month? This month, you just finished it. Okay.
It's all about perfect
We're going
timing.
to require a little bit of feedback as we go along, all right? But maybe not too much. All right, so we're going to do some experiments, and we're going to also try to get to your questions. The previous question we had is, what is your IQ? I have no idea. We have some weather-related questions that we're going to get to as we go over here. So we're going to adjust our presentation a little bit. But first and foremost, we got to talk about severe weather. Did you guys talk about that? Did you talk about tornadoes, tornado safety, that kind of thing? Not tornadoes? Is there a reason why we haven't talked about tornadoes yet? Okay, all right.
Like, we'll save it for them.
All right, so we're going to talk about some of the scientific stuff too, like density, condensation, how molecules work, that kind of fun stuff. All right? Share how you can keep you and your family safe. So let's go. All right. We're going to skip this rule. Usually we have a secret word so that everyone can quiet down, but you guys are sixth graders. Usually we're dealing with second graders. So we can handle this, right? Yeah. Okay, awesome. But the secret word is Fujita. It's not fajita, right? Everyone loves fajita.
Does anybody know where the word Fujita originated from?
Mexican.
Yes?
Go ahead.
Asia?
You know what? Technically, in a way, I think you're
You know
right.
what? You are right, but does it, I guess I should probably rephrase the question. Does anybody know how the word Fujita relates to weather? You're on the right track with tornadoes. Yes? You're very close. It's related to wind speed. So it's actually based, there's a scale called the Enhanced Fujita Scale, or the EF scale. And what it does is it measures wind speeds from a tornado, and it judges it from 0 to 5, 0 being the weakest, 5 being the strongest, and assessing tornado damage.
It's based on how much damage is done. So if there's a 2x4 that goes through a tree, you can estimate that it's probably an EF5 tornado. If the tornado takes a couple shingles off a house, no big deal. It might be just an EF0. If it picks up a car and throws it about a mile, it's an EF5. In between is where all those differences occur. They take what kind of tree it is, if it's an oak tree or if it's an ash tree, and if it rips it out of the ground, that's one thing, but if it knocks it over, that's another. All that stuff can happen. Wood can be driven through curbs in some of the strongest tornadoes. We don't have the coolest pictures to show you as far as tornado damage goes because it might scare little kids. So my apologies since you're not little kids, but usually we don't have some of the stuff like the ripped up helicopter that used to be on top of a hospital that didn't make it through a tornado.
Have you guys watched the Twister movies? There's a new one coming.
Yeah.
We have watched the first one that came out. Yeah, we have seen the first one before.
Absolutely.
We're probably going to end up going to see the one that's coming out.
We're gonna try to organize a watch party for the second one. I mean, we're meteorologists, so we're gonna talk about twisters. Questions as we go. Go for it. No, you raised your hand. What's up?
I just wanted to ask if how many people are invited to this watch party?
We're gonna figure that out later. That
We'll figure that
trailer,
out.
the trailer just dropped on Sunday.
Yeah.
we got to figure out what's going on here. All right, if this is Twisters related, this is the last question.
Watch it at my house.
Sweet.
Yeah.
I bet you have a great basement.
Yeah.
All right. So, along the lines of this, Ted Fujita was a scientist who studied tornadoes, and he realized that things were different depending on what tornadoes hit. There was an outbreak in the 1970s where there were dozens of tornadoes over the course of a couple of days, and they did a lot of different sorts of damage. He studied them very intently. We're going to talk about thunderstorms. What's so dangerous about them? What is so dangerous about thunderstorms? Right there.
Lightning.
Lightning. You can't have a thunderstorm without lightning. Why is lightning dangerous? Right here.
You can get shot.
You could get
Yep.
shocked. How bad could you be shocked? Dead. Exactly.
Yep.
So is there a way to prevent that?
Don't go outside.
There we go.
There we go.
All right.
Don't put a pan over your head.
By the way, is there anybody who's willing to test this? That won't work for you. Over here. What's going to happen if we rub this on your hair? Okay, do you want to try it or no? That could throw off your whole day. I understand.
I'll do it.
All right, really? Okay, there you go.
It's just my hair.
I can tell you've done this before. All right, so
There we
did
go.
you all see that? Here, still leave it. What's happening there? Static. What is static? Right here. Electricity. What's going on with that? Tell me a little bit more about it. Why is her hair standing up? Okay, that's a good answer. Yes, it does want to. That's how electricity works, right here.
Because two objects rub together real fast.
And it caused a separation of charges. You notice on a battery there's a positive and there's a negative? Same thing happens with electricity. You get the separation of charges. It happens in a storm because there's ice, there's water, it's going up, it's going down. The speeds in some of these thunderstorms of the wind is about 150 miles per hour upward. It has to be that strong to support something like a chunk of ice the size of a baseball. So if you have baseball-sized hail, it's going to be a lot of force to hold that up in the air. You were ready. I know you were going to catch that. A lot of hailstones are a little bit smaller. We're going to get to hail in a little bit, though.
Yeah. Sometimes they can also be even pea size, or they can even be even bigger than what that baseball is. But you'll see in just a moment. So each of y'all are going to get to vote. You only vote once. Randy and Brandon, they got their little binoculars out ready to go just to make sure nobody's cheating. So we're going to show videos on each of the different things within thunderstorms. So lightning, hail, wind, tornadoes, and flooding. First up, we have lightning. We have lightning versus a power pole and lightning versus a tree. Who wants to see lightning versus a tree? Lightning versus a power pole.
That's going
Really?
messed up, bro.
That's
A lot of people that love electricity here. All right, it's going to happen really fast, and then it's going to play in slow motion. Pay attention on the right side there.
I love that.
It'll play in slow motion.
Why did you want
Now imagine you're driving and you go to see something like this happen completely out of nowhere, like 100, 200 feet away from you tops. Now the good news is that this person is inside of the vehicle, so odds are they are going to be okay in this situation, but sometimes you could also strike a tree, which could cause tree damage, and sometimes that could damage your car if it were to fall on your vehicle. So as Randy said, all thunderstorms contain lightning inside of them. There's usually about 100 or so fatalities every single year. We having some technical difficulties?
No, I messed it up.
You're good. It's okay. So yeah, about 100 fatalities or so every single year as a result of lightning, and all thunderstorms contain them. Usually there's that negative charge that's more up in the atmosphere, trees, the ground closer towards the surface, a little bit more of that positive charge. So you have that connection, that separation of charges that Randy was talking about as well. So sometimes you can have lightning that just goes from one cloud to the next, but other times you can have lightning that goes from the cloud all the way to the ground. In that case, it struck a power pole, it can strike a tree. Bottom line, get indoors. As long as you get indoors, 99% of the time you are going to be safe from lightning. Even inside of a car, you are going to be better than being out in the elements. If you ever find yourself in a situation where you cannot get indoors, get into a ditch. But you don't want to be standing up like what I am because you're going to be that much higher up. You also don't want to completely lay down because you're going to be a bigger target on the ground as opposed to just a really, really small object. So just kind of crouch down a little bit and getting into a ditch. But odds are, get indoors, get inside a car, you're going to be much better off than if you're out in some.
If there's a thunderstorm, do you get in a boat and go in the lake?
No.
Do you go
Exactly.
golfing?
No.
No. Some of you say yes. It's not going to work out that well. No one's going to make you not do it, but it's just not a good choice. By the way, I'm going to veto your vote. We're going to look at the tree too. All right, guys, just hanging out outside.
And you can see he's actually going to go inside in this video here. Pay attention to that tree in the middle.
Is that a doggy?
Is there a dog? There might be a dog.
Because this guy was seconds away from suffering serious injuries. It's not done yet.
Oh, the doggy.
Now imagine all of those branches falling on top of you. That could cause serious injuries. Depending on where it strikes you at, it could even kill you outright. Or even if you're driving, as I was mentioning earlier, sometimes you can be driving, or rather in an area where there's a lot of forest, and some of those trees potentially end up falling on top of you, or it's on top of your car or something.
Okay, we cool on lightning? Awesome. How about flooding? I heard a
Flooding
verbal
versus
vote.
semi.
Motorcycles?
Semis are boring.
Semi.
Semi wins. Oh.
Yes.
Oh man, I hit spacebar instead of click on it. My bad. I guess we're gonna watch both of them. Oh no!
Why would you switch it?
Does anyone, who thinks the semi is going to make it across?
No, not even.
Can any of you see a road there at all?
You know, it looks like the
You're
driver
close.
kind of overestimated where the road would be.
The driver was okay, yes.
No.
I mean, he's probably scarred. It's probably not something you want to remember after doing that.
What was in the semi?
When was that?
No, what was in there?
I have no idea. That's a good question. I have no idea what they were carrying. Okay, flooding. Flooding is the #1 severe weather killer. 200 people each year, 75% of the fatalities occur at night because you can't tell where the roads are sometimes. It's usually people who are driving and they think I can make it. Because what happens when water fills a roadway, fills a ditch? It's affected by gravity. So it's all flat. It looks like a flat surface, but the road itself could be going down quite a distance. It could appear like the water is only about 6 inches deep, and it could be 6 feet or much more. So you don't want to cross that roadway.
Not to mention driving at night, it's going to be much more difficult to see some of that flooding a little bit. In some situations, you may even drive into some of those flooded waters without even realizing it, and then you have to make a very quick, split-second decision to try to get out of that situation as quickly as possible. But ideally, you don't want to get in there in the first place. Look at all those school buses there. You think they're taking y'all to school today?
No.
Exactly.
Yeah.
I mean, it kind of looks like they could, though, but they're not. Turn around, don't drown. Makes sense? It's what the National Weather Service likes to have, is kind of their key word there. Turn around, don't drown. Don't cross flooded roadways.
That's a whole house, by the way, in that picture on the right.
So, stuff like this actually does happen around here pretty close to us. Has anyone been to Whitewater State Park? Okay. If you've been to Whitewater State Park, not too far east of here, if you've been to Forestville State Park, these are areas that flooded incredibly in 2007, where there were literal homes that were washed away. One of the stories I remember seeing when I was covering that flood in 2007 was our reporter standing on the train tracks while a house was on the train tracks behind her. Because we're talking about a very narrow valley, a stream that, you know, you could go trout fishing in that's usually only about 6 feet wide. It flooded, it hit these homes, carried them around, dropped them on these higher spots. Like that.
Austin had some pretty bad flooding in 2004 as well. That's another event where there was a couple feet of water. It was causing a bunch of debris. Not quite as bad as the 2007 flood, but still pretty significant. So next up we have hail. We've got large hail, and we've got lots of hail. We want to see large hail.
Oh, yeah.
Lots of hail? I think large hail's got the win here. Click on it. There we go. Now pay very close attention to the sound of this video.
One that's
To
not
some of the
been
audience.
playing lately. There we go.
that?
The windows are great.
Exactly.
Sounds like there's a cat.
You nailed it. That is windows that are breaking. Do you think this person is making a very smart decision right now? Recording. Exactly. Very poor decision that this person is making. They do have that column there that's protecting them a little bit, but every time they go to peek through to see what's going on, they are only jeopardizing themselves more and more in this particular situation. That's what it looks like more outside. You think you're going to want to go in that pool or hot tub or whatever that is?
No.
You think it's going to be very fun having all that hail hitting your head while you're trying to swim?
Depends on how deep the pool is.
It's bubbling, yeah, it looks like it could be a bubble bath, right? Not
In
at
a
all.
whole nother sense.
Real quick, baseball players, softball players. Do we have any baseball, softball players in the room?
Quite a few.
Who's a big fan of Major League Baseball? All right, in the back, what's the fastest pitch that a pitcher's going to throw the ball?
Fastball.
Fastball. How fast? What's the
500
speed?
miles. If you get the right pitcher, 90 to 100 miles.
90 to 100 miles per hour. If you get dinged in the noggin with a 100 mile per hour pitch, it's going to hurt. It's going to hurt, even if you're wearing a helmet, right? Okay, hail coming down from a thunderstorm is going to be faster than 100 miles per hour, coming straight down. It's not only being driven by what? Gravity, okay? It's also going to be driven by the downward wind speeds. Winds are going up to support the hailstone, to cause it to develop. It's going to be floating in the air and freezing, all right? And it's going to be coming down equally as fast. So, it's a good idea to stay inside, right? Okay, I think we got that covered.
And in some situations, the hail can be even bigger. Who thinks they know what the biggest hailstone on record in the U.S. is?
Isn't it like the size of a basketball?
Close. Not quite that big,
You're close.
but a soccer ball. 8.2 inches. And it
Oh, yeah.
happened not too far away from here, actually. Vivian, South Dakota. So only 5 or 6 hours or so away from here. And keep in mind that when this hailstone hit the ground, it had already been on the ground for about 30 minutes or so when it was measured. And because it's super warm outside and it hail, it's a bunch of ice crystals, that hail is actually melting a little bit as it's falling to the surface. So that hailstone was likely even bigger before it was measured.
Hail has layers. It also can have spikes on it as it forms. Has layers just like onions and just like what?
Track.
Just like ogres.
Just like ogres. Yeah, okay.
What happens when it forms is it's going up, it's going down, it's falling, it's getting picked up again. So as that cycles through the atmosphere in that supercell, in that thunderstorm, it's going to get those layers. Go to a safe shelter, you see the windows are blown out, that was hail in a house. It's going to take out siding, it's going to take out windows, getting to an interior room, staying away from windows, all good ideas.
Absolutely. You think you're going to want to have your Bugatti outside when there's a hailstorm taking place?
No.
Yeah, because that's what's going to happen, is you're going to have all the windshield's going to be all busted out.
That's good.
Or hopefully you have good insurance at the very least.
That's what your backup Bugatti is for. All right.
All right,
Talking
everybody.
about wind, extreme wind, or with buildings. Which one do you want to see? You know what? Let's just watch both. Yeah. Let's start with just extreme wind.
Oh,
Oh man.
What the what?
It is a dog. It's cute.
so you can really see how visually you can see how strong it is with just all that wind coming in there. Pay very close attention to that tree, because that tree, you think it's going to stay up for much longer?
It's gonna get eaten.
It's struggling a little bit. If you listen closely, you might be able to hear some of that, the branches snapping a little bit.
I only hear wind.
It might be a little bit more difficult to hear in the back. But eventually this tree does fall over, and you can
We
see
promise.
a bunch of other branches in that driveway too.
Oh.
So severe weather guidelines are wind gusts
Whoa.
58 miles per hour or stronger. Yeah, that's definitely much stronger. That's probably closer to like 70, 80 plus miles per hour.
And a low end tornado can even be less than some severe winds, like an EF0 can have some close to 70 miles per hour or less, and then you ramp up more. But yeah, to do damage like this, you're starting to get into the 80, 90 miles per hour, and sometimes wind, it's going to vary a lot as it goes too. Usually people will say things like, well, it had to have been a tornado. Not always is it a tornado. You can have thunderstorm wind gusts that are, without a tornado, up to 100 miles per hour, doing a lot of damage too.
Oh, hang on a second.
I think you got it.
Yeah, I think I'm gonna click the actual play button. All right, pay attention to the roof of this apartment building, hotel. Yeah, you think? Yeah. Bottom line, get indoors. You're gonna be safe from getting hit by most of this debris here. There's a video that's gonna be coming up here in just a few seconds that really showcase some of this. You think this person that's outside recording that damage is making a smart decision at the moment? No, definitely not.
Storm chasers, they call their website Ultimate Chase.
Pay attention to this garage, something right here. And next thing you know, your car, your Bugatti, is now exposed to the elements once again. Looks like there's a little bit of flooding taking place in that particular thunderstorm as well.
It could have been. So by the way, when you're outside and it's windy, it's usually not a problem, right? You've been outside when it's windy? It becomes more dangerous when it's the stuff. It's not the wind that's going to hurt you, because a 100 mile per hour wind is going to knock you down, but it's the stuff that gets picked up that becomes debris, that becomes missiles. Anything like a paint can, anything that's going to be picked up by a 100 mile per hour wind is going to hurt you. Okay, so like we say, everyday wind is not so harmful, but we've got somebody standing outside. This is on top of Mount Washington Observatory. This is in New England. This is where they have some of the fastest wind speeds in the United States. 109 mile per hour wind.
Yeah, and keep in mind this is at 109 miles per hour. There are some hurricanes or even tornadoes on record that have wind gusts that are nearly double these winds right here. So if you think it's hard to hold yourself up at 109 miles per hour like what this guy's doing right here, anything close to 200 miles per hour, forget about it. It's just going to be nearly impossible to hold yourself up all that easily. And just like with hail, you're going to want to make sure to stay away from windows, because sometimes those straight line winds can be strong enough to where it can actually blow in some of those windows, especially if that glass is really thin.
By the way, I want to make sure we're aware of time, Brandon. If you could find like a few questions over there, that would be great for us to address as we're going along. We want to be able to make sure we cover all of our experiments too. All right, a tornado, you get to pick. You want to be inside one or see what happens to a barn?
I think everyone's going to pick inside one. This is usually one of the unanimous. You're going to kind of get a bit of a double whammy. The tornado's coming in on the left. This person is inside of that car right there. And then there's that little, it looks like a house or a barn or something right there that just gets totally demolished. And then the tornado continues on.
By the way, I don't want you to feel encouraged that you could be in a tornado by this video.
Yeah.
We were lucky to get the video.
Yeah,
if you're
this
in a vehicle and you get hit, that's a terrible place to be.
This person inside of this vehicle is extremely lucky that their car didn't get like tossed or something. And then we'll just go ahead and show you a video from a little bit of a further distance. Pay attention to this red barn right here in the distance.
Bye-bye.
Oh, no, it gets...
Bye-bye. It's decorations, it's confetti.
It almost does look like confetti. By the way, typically barns are one of the first structures to go, and the first part of a home to go is usually the garage. Does anyone have a guess as to why that is? Blue shirt. True. There's another reason as well. That's not wrong.
There's no pipes or anything?
There's no pipes? Yeah, there can be, but you're right. There's a little bit of lack of structure. There's a primary reason why, and it has to deal with wind and volume that's open to that wind. So the barn doors, there's going to be more open area where the pressure is going to increase into that building. A garage door on a house is usually the first part of the structure to fail. So when a garage door is broken, it's going to be a lot of wind and a lot of pressure within a large space as opposed to just a doorway. Yes?
Because like Yeah, because like the doors on those are a lot bigger and they're like a lot more like empty.
Yep. And there's a lot of pressure
Yeah.
from that wind. So
Not to
the wind-
mention some of the walls and some of those doors themselves are much weaker than the doors that you find in a residential house or some of the walls that you find on a house or even much bigger buildings.
And all your answers were right too. Lack of structure that's in some of these too. Yeah, way back.
Miss Johnson said it was because of the big door.
Big door. Way to go. All right, Tornado, what do? We all know what to do, right? You go out, play a round of golf, see if you can do a little bit of fishing. No, you don't want to do that. You want to get inside, get into sturdy structure, go to the lowest level, get into a small room. If you don't have a basement, where do you want to go? You don't have a basement. Right here. Yeah. Inside, away. Bathtub. That's a good option. Absolutely. Right here. A room without windows. All of this. Were you going to say that? Okay. One more.
Your neighbors, or somewhere that doesn't have, or somewhere that has a basement.
Someone that has a basement.
Or, like,
You know what? Most people, even if they don't get along great with their neighbors, if there's a tornado coming, you could probably go knock on your neighbor's door and say, hey, you got a basement, can I come over? They're probably going to say yes.
What if they're mean and they hate you?
Well, then you got bigger issues that you should probably talk about with them before a tornado warning comes. All right? I can't hear you. What?
Under your stairs.
Under your stairs, also a great option. In my house, that's the case. I live in a split-level house. Our interior closet is underneath the stairs. That's the one place without any windows. It probably has better structure than the laundry room. Right here.
During like a tornado drill, we always like stuff. What does that even mean?
Yeah, good point. One of the things we talked about before is one of the biggest issues with wind or tornadoes is the stuff that's being picked up by the wind. Everything that becomes what they actually call a missile. Anything that the wind picks up, from a baseball to a 2x4 to a helicopter to a book, whatever the wind picks up. Something that, yeah, we don't want to start throwing stuff around, but all that stuff. So when you cover your head, you're protecting yourself from the worst injuries. In case stuff gets knocked around, knocked down, because even well-built homes in the worst tornadoes can suffer significant damage. So you want to protect your head. Sometimes it's recommended, even if you have a helmet, to wear it. That's got to be a pretty bad one, and you really have to be thinking about that in order to do it. The only reason why I hesitate to recommend that is because the last thing that you want to think about doing when there's a tornado warning is going through a list of 10 things. You want to be able to take action right away, to take cover, and not go through a laundry list of things to do.
In addition, crouching down, the weakest winds inside of a tornado are going to be at the very base of that tornado. There's also a chance that if you ever find yourself in a situation where you can't get to shelter and you have to get into a ditch, sometimes the tornado may even skip over you outright and you end up getting lucky and not sustaining as much damage as you would if you were to try to drive in that particular vehicle. Notice how there's no roadways or anything close by. This is what can happen sometimes. The power of some of those tornadoes, they can really cause those cars and other debris to
That
fly
used to be a car. By the way, what are we talking about for end of class? Is it 9:50?
You're fine. You can
Okay.
do however long you
All
want.
right, sounds good. We'll pick up the pace a little bit.
No, take as long as you want.
All right, we talk about watches.
Take 3 hours.
We're really skip. You know what? Math is pretty important.
That's fun.
Yes, ma'am. That's a great question. So, in the event where you are in an airplane and there's a tornado, there's going to be a few things that happen. First of all, it's going to be upon the pilot, and I'm a pilot myself. You make the decision to not go flying when there's the potential of tornadoes, when there's the potential even when there's nothing but blue sky. You're still able to know from a weather briefing if there is, say, a tornado watch, a severe thunderstorm watch. Those conditions you never want to go flying. Sometimes what we call the heavies are going to go no matter what. So if they're flying a jet full of 200 people from Minneapolis to Denver or wherever, they're going to be flying into areas where there are thunderstorms. They have a radar on the front of the aircraft that's going to give them an idea of where the thunderstorms are located, and they'll avoid them. And then air traffic control will guide them around them. I have been in a jet airplane that was going through a squall line, a line of thunderstorms where there was a tornado warning, and it was terrifying. I don't recommend it. And it can be very bad news for those aircraft as well. And the turbulence is crazy. So usually they at least have, when they're going through thunderstorms, radar that shows them where the cores, where the heaviest precipitation is, so that they can go around it. But it's a terrible place to be. So usually they'll actually fly around it. So sometimes Minneapolis to Chicago, if there's a thunderstorm in the middle, they'll fly all the way down to Iowa and then go around and take a circular route. One question in the back.
If you're like a pilot, you have to be a scientist.
You don't have to be a scientist. I mean, you could be a novelist and be a pilot. But there's science in it and math. So math is pretty important stuff. Right. I wouldn't say that you guys are missing math. Am I right?
You're teaching us, so we're
What
taking
is
it.
it?
Yes, ma'am.
Oh, since you're a pilot, you think we can just like have a watch party in like Florida or something?
I can't fly those big planes. And you know what? It's been a long time since I've had a
We might have to
jet
make a
ride.
GoFundMe for that.
I don't think you'd want to trust me. Okay, we're gonna talk about what a watch is and what a warning is, and Spencer's gonna guide you through that. How many of you like tacos? Just about everybody.
Tacos are pretty popular. Okay, so a taco watch. You have your tortilla. You have your cheese. You have your choice of meat, whether it's beef, chicken, whatever you're into. Maybe you're vegetarian. Tofu's another option. Tomatoes, your lettuce. But the taco has not come together. We are quite literally watching for that taco to come together. But a taco warning, that taco is all the ingredients have come together. That taco is ready to be eaten, and immediate action needs to be taken. Eating the taco or something. So how does this relate to, say, like a tornado warning or tornado watch, for example? We are watching for conditions for a possible tornado to take place in the event of a tornado watch. But a tornado warning means there could be a funnel cloud, there could be an active tornado that is on the ground, and you need to take immediate action to avoid that tornado.
So watch, the ingredients are there, but they haven't come together yet. Maybe we need time. Maybe we need things additionally to come in for that to happen. Still got to go to the store to buy the cheese. You still have to wait 4 hours for the temperature to hit 85. That's the watch. The warning is when it all comes together. Yeah?
Why tacos?
Why tacos? Why not tacos? Ask yourself that question. Yes. What's that?
Can I eat the taco?
Well, yeah. I mean, that's when it's the taco warning, right? It's there.
It's raining tacos.
It's imminent. Okay, enough with the tacos. You guys got the watch and the warning bit? Watch means to watch out. The ingredients are there, but they haven't come together yet. A warning means it's happening. All right? It's happening right now. Now, the tricky part with the tornado warning is we could be on TV and we could say there is a tornado warning for Dodge County. Tornado is in Hayfield or near Hayfield, but we also go by radar indicated warnings. So if there's a radar indicated tornado, that means that there's rotation that's being seen in that thunderstorm. It may not mean that there's an actual tornado on the ground, but there could be any minute. Okay? All right.
In some cases, it may not go beyond radar indicated if there's a lot of precipitation. Like if it's raining really hard,
Hold off on
it can
the
make it very tough to spot some of those tornadoes as well. So in those situations especially, well, in any tornado warning, you want to take shelter, but in those particular ones, it can be a little bit dangerous.
All right, so there's the thermal. Okay? All right, let's do some experiments. We're going to be talking about molecules, air pressure, and air motion. All right, so the first one is molecules and density. By the way, we're not very dense right now.
No.
But as we move closer to each other, our density increases.
So do y'all think you are less dense or more dense right now?
More.
Exactly. You are more dense.
Yeah. We don't mean that as an insult either. All right, so the first experiment that we have for you is a pretty simple one.
I have a can of regular Coca-Cola and a can of Diet Coca-Cola. I would not recommend drinking these though. I think these particular cans are expired at the
I'll
moment.
never.
But,
I'll drink it.
but anyways, I'm gonna put them inside of this water right here, and I'm gonna see if they sink or if they float. Who thinks the regular Coca-Cola is going to sink? Go ahead and raise your hand. Who thinks the Diet Coca-Cola sinks? Who thinks they both sink? All right. Well, not as popular of an answer. Actually, you know what? We'll do regular Coca-Cola first since this is a more popular answer.
Oh, I think
Oh, that's
It's the same.
Wrong.
And then you're just gonna.
That one's gonna float.
Was that because that?
What?
I knew it. Because it's not.
We'll put the question to you. Who said the Diet Coke was gonna float? I heard it. You know why?
Because it has less, like.
Go for it. Why? Yeah, you were just raising your hand, right? Did you say it?
I heard somebody
There's
say
less
less
sugar.
calories. You're on the right
No
track. When you,
sugar.
There's less
I
sugar
heard
and
you're on the
density.
right track when you say less calories. So there's a very specific ingredient in the Coca-Cola that causes it to sink. It's the sugar. The sugar inside the regular Coca-Cola is more dense than that water, and then that causes everything to sink to the bottom. That can, the aluminum can, all the other ingredients in the regular Coca-Cola, whereas the Diet Coca-Cola does not have sugar in it. And the aluminum can, all the other ingredients in this Diet Coca-Cola are less dense than this water, hence why it was able to stay floating. That sugar makes all the difference.
Okay.
But there's another way
Oil
that
and
we can
water.
showcase.
Oh yeah. Oh, this is gonna be like the duck commercial for
Can
Dawn.
I have
The duck commercial. Oh, I know what you're talking about.
I'll say I don't know if I've seen that particular commercial. I don't know if it aired during the Super Bowl or when necessarily, but how many people have heard the whole thing about oil and water? They just don't mix. Most of you probably learned. Yeah, exactly.
You ever
So-
heard that about people? Someone says, they're like oil and water.
Yeah.
They don't get along so well.
So, who thinks the oil is going to end up on top of this water here? This is just water with purple food coloring, by the way, meaning that it's less dense than the water. Who thinks the oil ends up on bottom? Only one way to find out.
Is it on the top?
It started on a little bit of it went to the bottom just by the sheer force of it going into the water, but you can see it's already started to come back to the top a little bit. Over the next few minutes, it's only going to separate a little bit more. And even if I go to try to mix some of this together, no matter what happens, it's going to separate. Now let's say we were to put like maple syrup or something. How many people in here love pancakes? All right. How many people love their pancakes with syrup on them? Let's say you were to put syrup inside of this. Do you think it would end up on top, in between the oil and the water, or on bottom?
In between.
Most of you said bottom. You'd be correct. Why is that?
It's more dense.
Exactly. It's got the sugar in it, just like in the regular Coca-Cola. It's got sugar in it, and that would you all learned just a few minutes ago that sugar is more dense than water, so it would cause it to completely sink to the bottom.
You know why Spencer uses purple and gold? Huge Vikings fan. Huge. Actually, I'm giving him a hard time. He knows he's a
Yeah.
Lions
Hayfield
fan.
Vikings.
Hayfield
Hayfield
Vikings. All right. So we're done with oil and water?
Yes.
Right? Okay. So we're going to talk about making a cloud.
Yeah.
All right.
That's what the airplane's up in the sky.
Yeah, exactly. So, something called, and you have to do a lot of math for this one, the ideal gas law. The ideal gas law means that as the pressure increases, the temperature increases, and vice versa. So as the pressure drops, the temperature drops. So what we're going to do is make a cloud using pressure. I love clouds. As a meteorologist, a cloud is going to make a good snowstorm. It's going to make a thunderstorm. It's responsible for tornadoes. I'm feeling a lot of pressure here. Okay, not much pressure right now, okay? This is open. So, I'm going to pressurize it. I'm going until I can't hold it anymore. All right, are you ready?
I knew it was coming, even I jumped a little bit.
Do that again.
So we made a cloud. Because what happens is I pressurize it, high pressure, stabilizing it. It's also raising the temperature a little bit.
I told that for like 5
And
minutes.
as the pressure drops, when I release it, what's happening?
It's closed.
What's happening with the temperature in there? It drops. And then what happens?
Then like the warm air from outside mixes with the cold air in the bottle, and then it forms a cloud.
Yep, there's condensation then.
Whoa!
Nice catch. Still a cloud, right? It's the first time I've dropped a cloud.
I don't think I've ever seen that happen before.
Stanley caught a cloud.
You can't drink the cloud, but there's condensation that occurs as the temperature drops. The dew point stays the same. Temperature drops down to the dew point, condensation occurs, cloud forms, dew forms, stuff like that. Okay? What's our next one?
Yeah, plunger pulls.
Plunger pull. Brandon and Spencer are going to perform this one. Uh-oh. We got to make sure we've got a good seal.
Yeah. Normally I'm not able to pull that apart by myself, but guess we didn't have the best seal on this one.
So what this is showing is the power pressure. Okay? So when we have these two suction cups, nothing is actually, there's no force in there because we're removing the air. So then all we have is the force of the atmosphere working against that and the absence of air in between. Not a perfect absence of air though. That would be really difficult to make. So, two strong guys pulling. Careful.
Pull me over.
So that's hundreds of pounds of force right there. You did a good one.
Good one.
Can we try?
I think we might have dislocated Brandon's shoulder. Are you okay?
Ouch.
I'll say, you okay? It's probably the best seal we've ever gotten on one of these.
You might need a volunteer for this
Yeah, I
one.
could have out.
Try the other arm.
So, what we're showing is the force of the atmosphere.
Here, we might want to do this in front, that way we're not tripping over anything back
Well,
here.
I'm going to stabilize.
Should see if one of you guys can
Ah.
hang off of it.
Wow, that really is aggressive.
I could.
How many of you have swam to the deep end of the pool? What happens? Your ears, you're feeling it. What are you feeling? You're feeling pressure. The atmosphere is a fluid, just like the pool is water, it's a fluid. So in that fluid, as we are now at the bottom of the pool, essentially, of the atmosphere, we are feeling that. What happens when you get up in an airplane or you drive up into the mountains? Your ears pop. Why are they popping?
Pressure.
Okay, I think we all got that one there. Air pressure. All right, balloon in a jar. I love this one, although last time the fire didn't go out.
What?
You know what? It's science. Sometimes it doesn't work.
Don't worry, we didn't cause any damage.
Snap it, fine.
Oh, yeah.
Pay close attention to the bottom of the balloon.
That thing is going to just melt and pop.
No, it's getting sucked up.
So the bottom of the balloon is doing what?
It's sucking in.
So the bottom of the balloon, see, it was answered over here, is drooping. What's actually happening in here is there's a change in temperature. I started a fire when I burned the paper. The fire went out. And it went out because there wasn't enough oxygen to keep it going.
Yeah.
Now, I got the balloon on a little bit late, but right now, the balloon has been pulled in there.
Like shaking really.
Why is it not popping right now? Because the fire went out. But there's pressure on it right now, and there's pressure on the balloon that's pulling it in because the temperature dropped. I brought the temperature up with fire. The fire went out. I put the balloon on top of this, and as the fire was out, the temperature was just dropping. Now, if I was able to get an ice cube or something in there and get some really cold air, it would go even farther, pull it in. It might even be enough pressure to cause it to pop. But right now, that pressure change, because only the change in temperature is drawing that in. Cold air, low pressure, pulling it in. Well, it's a balloon. It'll come out pretty easily. We're not going to do the can crush.
No.
It's like the same as cupping, isn't it?
Yes, exactly. One of my favorite things, I was just telling somebody about it yesterday who's never heard of that before.
Myself, right?
Yeah, yep. You get cupping, they start a little fire, the fire goes out in it, and it causes pressure. Exploding paint can, we're going to talk, this is more of a chemistry experiment, but it is a pressure experiment. We already got permission, but we do apologize in advance for any damage we caused. Okay. There is no paint in the paint cans. Alright, and just a heads up, there will be a pretty sudden reaction here, but everyone's going to be safe, alright? Okay, count down from 3.
3, 2, 1.
I don't know if it's gonna pop because I had to hammer it on a little bit.
Yeah, I'll take a cup.
Bye-bye. We're going to give it a little help because these are new paint cans.
Uh-oh, jump scare. Jump scare.
I might have actually hammered those on a little too tight.
Uh-oh. Yeah.
Jump scare.
You know what? I know we got the point across here. We have to do 3 because we can't have pressurized paint cans when we're driving back home.
Almost caught it.
Jump scare.
So a couple things happening. One of them was a chemical reaction because we mixed vinegar and baking soda. So there was a chemical reaction, but because of that chemical reaction that occurred, it created an increase in pressure in an enclosed environment. So the pressure was on the lid. That's a pretty strong lid, thank goodness, especially if you're carrying around things that are dangerous like lacquer or alcohol-based paint. You don't want to have the lids popping off. It's a little bit of a mess, though.
Yeah. Not to mention, it bursted out through the weakest part of the paint can, which is where that lid is at. As soon as that pressure was able to release, Randy using his key was able to get that lid off a little bit more. That pressure was finally able to release. That instantaneous reaction of that pressure release allowed for that lid to break.
Meteorologist Brandon, see you later. He's got to go do the 11 o'clock news.
You're famous. You're famous. He's famous.
Oh, I can't stay out of
All right. Air is a fluid. Air is a fluid. You can feel it if you put your hand out the window when the car is driving. You can feel the fluid, right?
Yeah, I gotta make sure it's straight out.
Adjust it a little bit. It's just not perfectly straight. Sometimes it is. Theoretically speaking, we should be able to turn that on. There's a constant fluid pressure.
Here, use the baseball. So what's happening in this particular situation is we have higher pressure directly around the ping pong ball, but there's lower pressure where we have those dynamics taking place at, where there's that updraft, which is one of the main ingredients in a thunderstorm. That updraft is also very significant for hail, like what we were talking about earlier. Eventually, the size of the hail becomes so significant that the strength of that updraft is no longer able to hold that hail up, and it eventually falls to the surface. Sometimes it can be ping pong ball size, like we said, baseball size, or even soccer ball size, like what we were talking about earlier.
And it took, the ping pong ball was being held up 3 feet. Baseball is like half an inch. It takes a lot more of that pressure to keep the bigger stuff up there.
Whereas if we put the soccer ball up there, it wouldn't even move. I don't even know if it would stay up there because of how tiny that particular hole is in the vacuum.
So there's a guy who figured this out, Bernoulli.
Yes, Daniel Bernoulli is principle is named after him. Air molecules, they do not move by themselves. They move as a pack, almost like a pack of wolves in the woods, or a flock of seagulls when they're flying in the sky, when they're flying in those V shapes. And to help demonstrate that, we have these Bernoulli bags. And for this experiment, we need a few volunteers.
And we have a very eager, I'll pick one here, you pick another over there, right
Okay.
here.
Oh yeah.
Okay?
Let's go.
Purple.
Red,
Come on.
red, all the way in the back.
Can I win?
Can you win?
That's going to be completely up to you.
Right.
And then let's go ahead and go with the blue Under
So
Armour
one
shirt.
gets to hold, we'll switch, so you hold it so that he's got a straight shot. We can switch around too.
All right, come on over here. So here's what's going to happen. One person is going to hold one end of the bag and try to blow as much air into it as they can in 10 seconds.
The team that has the bag filled
Gonna
first
hold
is
the
the
other end
winning
of the
team.
bag, just to make it a little bit easier for that person to blow up the air. Whoever has more air in their bag after 10 seconds
Hold it really tight.
wins.
All right, hold on, hold on.
Hold it really tight.
Plus, you gotta make sure you're going from zero.
Come on, you ready?
Come on, Graydon. Yeah, I do.
Are you ready? Okay. Are y'all ready over here?
Come on, Graydon.
All right. Hang on a second.
Come on, Graydon.
Ready?
Come on, Graydon. Let's go.
Go.
Go, Graydon, go.
10,
Come on.
9, 8. Everyone count 7.
6, 5, 4, 3, 2, 1.
I won.
Graydon, you don't know that.
I think so.
Oh yeah.
Oh, Graydon won.
Oh, yeah.
Yep.
Oh, yeah, Graydon.
Yeah.
Not bad. Now, who thinks Randy can blow up even more air into the bag than any of our volunteers?
Do I have 10 seconds to do
You
that?
have 10 seconds as well, Randy, and we gotta be fair. You ready?
I'm ready.
All right. Set. Go. 10, 9, 8, 7, 6, 5. Come on, you only got 5 seconds.
Wait,
That's a smart
wait, no, wait.
So, what happened?
So, Randy was using. Go ahead. What do you think happened?
You're blowing air into it, and the air around it gets sucked in with it.
Exactly. Randy is using more air molecules. He's further back. He has more air molecules to work with. Our 2 volunteers, they had the bag right up against their mouths, so the only air that could sneak in was whatever little air molecules could sneak between their mouths and the bags, and whatever air they have in their lungs.
And our lungs are probably pretty close to being about the same size. So, it's one of those things where you gotta work smarter and not harder. Because if you were to just keep blowing and blowing and blowing, you'd do what? You'd pass out. You'd run out of air. But just by putting 2 breaths in there, I almost filled it up. Because by keeping a distance and blowing in, all that surrounding air was going in as well. That is also, let's talk about the movie Twister for a second. And also the movie Superman, I think. The new one, where there's a tornado coming and everyone decides to take shelter underneath a bridge.
Oh.
Right? And in the new Twisters movie, in the trailer, that doesn't come out till July 19th, watch party in your basement. That movie shows, in the trailer, there's a tornado coming and they take shelter underneath a bridge. What's going to happen is as the tornado has wind speeds, maybe up to 150 or 200 miles per hour, those wind speeds will actually accelerate underneath the bridge. So while a bridge could be a great place if you're driving a motorcycle to hang out while the rain comes to an end or while the hail ends, it is not a safe place to be. It's a more dangerous place to be in the event of a tornado because the wind speeds will actually increase underneath that bridge. All right? Cool. What else we got? Oh yeah. Should we go to the toilet paper list?
Yeah. Me with it. I want to get TP. Can you TP me?
Can't really do that one.
terror.
Oh, yeah, we're the right side.
Why is the other one
I
T
think
T
we're the
terror?
right side. Okay. 3, 2, 1, go. Uh-oh. Oh, hang on.
T terror. No, Landon, let me.
I'll stick it out.
So why did that happen?
So, some of you are probably wondering why exactly some of this happened just now. So, there is low pressure underneath the toilet paper, and that allows for lift to take place. It allows for the toilet paper to lift up, similar to an airplane wing.
There's lift. High pressure one side, low pressure on the other side. When you have those differences in pressure, it's going to cause motion. You also just have fluid motion that's occurring with the fluid of air, and it's going to be driving that out.
Now, let's say I were to flip this toilet paper over like this. What do you think would happen if I were to start the leaf blower? What do you think would happen? Exactly. It wouldn't roll back up. It would mainly just. It wouldn't be able to. But it wouldn't be able to travel as far. Oh, come on. It wouldn't be able to travel quite as far as it was able to. It's still doing pretty good, to be fair, but it's not doing quite as good as what it was when we had. It's not able to generate the same amount of lift as what it was when I was demonstrating it in the crowd earlier. But
Okay,
one more experiment.
we're about to finish, but we're not going to do the.
No.
We're not going to set it up. We're already 10 plus. So here's what's going on. So are you?
I love those.
What we typically do in a larger space, or maybe outdoors, is we would have a little smoke machine and we could show you what would happen. What kind of shape would be coming out of this? A circle. What
Be
it
a
look
little
like?
bit more specific, though. Would it be a cylinder? Would it be a sphere?
Be a ring.
Why would it be a ring?
So a couple things happening here. We're causing a rapid increase in pressure that's pushing the air out of this, and it's going to be out like a donut, essentially. And if we were all just standing here and if we were able to show you some smoke, we would have a ring that could travel across this whole room.
Whoa, I just got hit.
Not to get too preachy, but this is one of the reasons why you want to cover your sneezes. Because a sneeze could actually travel across this whole library because you're causing a major increase in air pressure and you're pushing that air. Just like this. Okay, so normally what we would do is we would have all the teachers come up and have a competition to see who could blow all the bricks over the fastest, but what's going to happen is the teacher who invited us is going to win an Air-Zuka for the class. And on that note, have fun, be safe with the air cannon. Okay. Thank you for having us today.
Hang on a second.
Oh.
Do we have time to explain it?
Yes.
Oh, to explain it? So, one more thing is you can also end up on TV. You have an opportunity where you can end up on TV. So, what you can do, we have on our website, KAALTV.com, you can choose from a list of experiments. A few of them are some of the experiments that we did today, and you could potentially be featured on air as a weather lab assistant. So here's an example. We should have a clip up here. Here are some of our previous assistants right here, just some photos of them with some of our previous winners. And some of the experiments that they did, anywhere from a shaving cream cloud to a rainbow in a jar, really just all over the place on some of these experiments. And I think we should have a clip of what it looks like on, I don't know if we have a clip of what it looks like on air, but basically what you'll do, just go to our website, Click on the link here to get certified, submit your name and photo. We will also be sending out cards here to all the students that have all that information on it as well.
Where are those, by the way? I can leave them with.
I think they should be on the table over there somewhere.
And you can always help them too. So there you can do your own experiments at home. There are quite a few things that you can do that are related to meteorology. Gosh.
Phil, can I try?
Anyway, we'll find it.
Here's an example of what it looks like on air. I think this might have her. This is our old chief meteorologist, Chris Kubel. Totally not. And that's what it looks like when it's on air. So I know some of the captioning there was kind of blocking things up a little bit. We pick a new weather lab assistant every single Wednesday. Next week we won't have an assistant. We'll be airing a special that has everything that we did here today, but after that, every week it's a weather lab assistant.
Okay, and we could use maybe a couple volunteers to interview after, well, and I'll let you pick who that's gonna be.
Please. I'm agree.
Okay.
Yeah, I would say about maybe 3 or 4 students.
All be okay? Let me reiterate that. You'll all be great.
Yes, I'll be
Yes,
great.
you'll be
I'll
on
be
the public
amazing.
record. Everything that you say will be saved forever.
What?
If you wouldn't say it to your grandmother, don't say it.
No, I would say it's my grandmother.
My grandma.
My grandmother would probably stop.
All right, Spencer, why don't you pick out a few and then we'll.
All right, perfect. All right, let's go pink shirt in the front. I gotta pick the maroon hoodie.
Oh yeah. Can Stanley do it?
Not me?
Yeah, if you two want to do it, go ahead. Let's go ahead and go with the blue shirts with the flowers on it. Yep. Oh, that's KAAL. I'm sorry, I couldn't tell. I couldn't know who was over here. And then the red shirt to that. Yeah, we can do double interviews.
What?
I think that should. I think that should be enough.
All right, me and Landon are doing a double interview.
This isn't fair.
So I don't know how you want to work when
Don't phase them.
everyone else is taking off. The interviewees could stay. It's up to you.
That's it.
Okay, so much. Everybody else, what do you say?
You're all go.
You all need to go, you have approximately 10 minutes left of third hour.